In this video, we are going to learn about how to create a schematic symbol and PCB footprint for a step-down transformer. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. This video is divided into 4 important parts. First one is understanding the dimensions and schematic symbol representation of this particular transformer. For important note, we do not get the exact data sheet of these kind of transformers which are available in market, because most of them are local made and most of them are not having any standard manufacturing data sheet. If you find one, that is awesome. Use it and based on that design it. If not, then you can purchase the transformer first and measure the dimensions and understand the schematic symbol and create according to that. Second step is creating a schematic symbol using EasyEDA, which includes IEEE standards and user interface as a priority. Third step is to create a PCB footprint according to the mechanically measured or manually measured the dimensions of the physical component in your hand. If you have a data sheet, you can refer that. In this step, we are going to follow the IPC standards and also a specific rules with respect to Cartesian geometry. Last but not the least, fourth step is to combine and create a component library by combining a schematic symbol and PCB footprint that we just created so that you can use it in your future project. So let's get started. The first step is to understand the schematic symbol and also a dimension of this particular component, which is a step-down AC transformer. This transformer is mostly used for designing AC to DC power supplies. A linear voltage power supply is where you provide a AC voltage, which is 230 volt 50 Hz frequency AC voltage to the input, and you will get the center tapped output, which may be a 12012 or 909 or maybe 505 based on what type of a transformer you want. And you also get the variety of these transformers based on the current rating. This one is 1 ampere transformer, that's why it is a little bulkier and a bigger one, wherein we also have a 500 milliampere transformer, which is smaller than this one comparatively, right? But still it is also a 12012 transformer. Like this, you will get these transformers from the local market for your project. But how do we mount them on the project or on the PCB? First of all, these projects or these transformers are not meant to be placed on the PCB. First thing, which is absolutely a necessary condition to be followed. But as a beginner, sometime we want to place them on the single board so that we can make our entire project on small PCB or maybe something like that. On that time, we need to understand how to create a schematic symbol and also PCB footprint on the PCB so that we can mount it. In case, if you don't want to place this transformer on the PCB, you can create a connector where you can connect the output of this transformer and input to the direct AC supply using a wire and all that thing, and mount this transformer on the panel or the box of that entire project, which is possible. On that case, you need to use only schematic symbol, not a PCB footprint. If you want to use that, then still you can place it and you can ignore it while soldering the component. But still, those permutation combinations are available for you. Now with respect to the screen, you can see that I have the representation of this transformer on an image format, where you can see the symbol is usually represented like this. Input of this transformer is indicated by I1 and I2, which indicates input for the entire transformer, and output will be divided into T1, T2 and T3. T1 and T3 are the positive voltage indicators, not positive directly, but it's AC voltage, so it's a reference voltages with respect to the T2 point. This kind of a transformer are called a center tapped transformer. This is a step down center tapped transformer. Why? Because it steps down the voltage from 230 volt to 12012, which you can consider 24 volt as well if you consider from T1 to T3. T3 as a reference if you consider, then it is going to be 24 volt. But if you measure it between T1 and T2 or T2 and T3, then it is 12 volt AC output. That's why it is a step down transformer. And also it is so called center tapped. Why? Because we have a center tap in the entire secondary coil, where it will help you to create a voltage as per your convenient. Now using this information, let's start with creating a schematic symbol in EasyEDA. I am on EasyEDA now, and I'll go to the file and create a new symbol by clicking on the symbol option. Here we'll bring the 4 pins on the screen first, pin number 1, pin number 2, and pin number 3, 4, and 5. So first thing is, we do not have a specific pin number or naming for this entire schematic symbol. It's all your understanding and your creativity, however you want to design it and however you want to give a numbering and name to those pins. So that's why make sure that you follow the standards and make it as easy to understand as much as possible for other designers. That's why it's so-called IEEE standard and IPC standards to be followed in the PCB industry. So first thing, I'll place these pins properly. Now what I will do is, I will disable the name of these component pin so that it is easy for me to create a representation of the diagram. Because if we keep a I1 and I2 here, it is very difficult to create that coil and represent the entire transformer design in a better way. We can represent them with those name also, we can remove those name as well. Make sure that you do not delete them. Instead, you can select the pin and disable it by using this option. Display name option is there. You can just make it as a no. That is the best way to do it. Alright, now it is time to create a coil kind of a structure on this particular schematic symbol. Alright, now we are done with creating a schematic symbol of transformer, which is the center tab. And one important thing is, I have created these coils equal ratio, which is not correct actually. You have to create a large number of coils at the input side or the primary side and small number of ratios on the secondary side. That's how we can represent a step down transformer in schematic symbol. But sake of tutorial, I'm creating it equally so that we can make it as a symmetric and continue with the tutorial. And after that, one important thing is, we do not need to add a border for this because border is not necessary for a transformer. And once you are done with these kind of a procedure, you can enable the name of these particular pin and see if it is really necessary. If it is necessary, you can place them like this and make it a visually better place or better understanding for the user. If you feel it is not good one, or if you are feeling it is not appealing for the designer, then don't worry, you can just disable them and continue with the design activity. Now it is time to save the schematic symbol. I'll hit the Ctrl S and here we can name it as a step down transformer. Supplier part number, supplier and manufacturer part number and manufacturer, all these details are unknown to us because most of these are Chinese made and there is no label or a part number or anything on this particular transformer. We can see there is a SRC transformer is written on this, but most of them are manufactured in China, so we cannot go with the name written on that particular part. Still, what we can do is in manufacturer section, we can write it as a SRC transformers, right? SRC transformers. is a manufacturer name, and manufacturer part number, they have given it as a 12012 because it is a 12012 transformer. So I will write it as a 12012. But still, that is not an exact part number which you can use to purchase this product in the internet. You can go to the local market and ask them, give me a 12012 transformer. They will give from any brand or any part number, but it will be a specification of your requirement. Current rating and voltage is what you have to tell them to get this particular part. And when it comes to tags, I'll name it as a transformers, which are already available with me, means that particular tag I have used for the previous design. That's why we have that particular tag available. In your case, it will be a new one. Just make sure that you give that particular name correctly. In description, I will write it as a 12012. Great. Once we are done with filling the all details in the saving section of this particular wizard, then we will click on the save. Once we are done with that, our schematic symbol for the 12012 step-down transformer is ready. Now it is time to create a PCB footprint in EasyEDA. For that, I'll go to the file, create a new footprint. Here, what we need to do is, this particular transformer is not recommended to mount on the PCB as I told in the beginning of this video. But right now, for the sake of tutorial, for sake of understanding how the footprints are designed for the transformer, we will be mounting this transformer on the PCB using a 2 mounting hole and using a 5 pads which are going to connect with this AC input and also output of this particular transformer. That is how we are going to design. And for this particular tutorial, I'm going to use a 1 ampere 12012 transformer dimension. We also have a 500 milliampere dimension, but we are going to use the 1 ampere one, which is the bigger one. And for that, what we need to do is we need to bring 5 pads which are going to connect with the AC input and also output of that transformer, and 2 mounting holes. For mounting, we can use the pads as well as we can use the specific holes. I recommend to use a hole. Why? Because we do want to connect the ground of the entire PCB with respect to the body of the transformer, which is not good one. So that's why we are going to use only mechanical hole where that particular hole is not connected or not mounted or connected with respect to the ground plane of the entire PCB. Now it is time to measure the dimension of the transformer in hand and use that dimension for the design activity. As we already said, we do not have any specific datasheet of this transformer. That's why I'm using the scale to measure it. After measurement, we got to know that the mounting holes are placed at 70 mm difference from one point to another point. Approximately 70 mm. It has an oval kind of a shape, so you can adjust it as per your convenience. So 70 mm is the mounting hole distance, and the total width of the transformer is 40 mm. This number looks very big because according to the PCB designing, these are very big. That's why I mentioned that these transformers should not be placed on the PCB directly. But right now, for the sake of study, we are placing it on the PCB. So 70 mm and 40 mm are the distance of that particular mounting hole and the body of the transformer. Placing the connecting wire plane or maybe these wires pad is up to us. We can place it anywhere after 40 mm width of the transformer. So let's do it on the EasyEDA. All right, after a lot of design work, here we have a creative transformer footprint design. Of course, it is all creativity activity, not related to IPC standard much. Why? Because we just wanted to represent what is a primary side, and the primary side is going to be higher voltage side, and secondary side is going to be a lower voltage side. That's why we used a stroke width in a different way. Why? Because on the primary side, we have a stroke width of 1 mm. On the secondary side, it is 0.5 mm. That is how we are representing output and input in this entire transformer design. And also you can see that the coil design and everything is created by using this arc center tool. You can use these kind of a tool to make a footprint design much more interactive and much more creative, so that when we are assembling the component on the PCB, a person or the assembly engineer will never miss a connection or never make any wrong connection. That's why we even given the input 1 and input 2 indicator, as well as a T1, T2, T3 indicator. I'm just making sure that the T3 number is a number 3. At the same time, on the schematic side also, T3 is having a pin number 3. Otherwise, what happens if you create a pin number 5 here and a pin number 3 over there in the schematic symbol? The connection will become a misconnection. However, this transformer pins, output pins are swappable. You can literally do that, but technically or logically, it is not right way to do it. That's why make sure that you give a proper pin number for the pads you're using on the PCB footprint. And also you can notice that the mounting holes of this entire transformer is completely outside the body of the transformer. I have considered the body of the transformer as a 60 mm height and width-wise 40 mm as measured on the physical transformer in hand. Now, using these two data, I have created a placement of those two mounting holes outside the body of the transformer, because physically it is outside only, not inside the transformer. And even though it is attached to the body, but it is outside the body of the transformer. Considering that is very important. Otherwise, what happens? You can place the transformer, but you cannot mount the hole, which is not at all good. That's why you should understand the Cartesian geometry and make sure that the mounting holes are also placed properly. And then I have used a 10 mm pitch for these pins or the pads on the PCB design, just as a random number. There is no logic behind it. I felt 10 mm is a good one, because when we see these pins, it is at least 2 cm away each other. Which is 10 mm from this side, 10 mm from this side. That's how I'm using the logic in this particular design activity. Now it is time to save it and complete the PCB footprint design. So while saving, we'll give a name as a transformer only, because we do not have a specific package name for this kind of a components in electronics. Here is one important point. Instead of giving a 12012 step-down transformer, I have changed it to 1 ampere step-down transformer. Why? Because it is not necessary that these kind of a transformer will come with a 12012 voltage only. You can go with a 909, you can go with a 505, even you can go with a 15015 transformer. But 1 ampere transformer will be having the same dimension. That is what a necessary point to be considered while designing the PCB footprint. That's why I have changed it. Now it is time to save it, and completely done with the PCB footprint for a 12012 1 ampere transformer. Now it is time to create a component library by combining the schematic symbol and PCB footprint of this transformer that we have designed right now. So for that, I am on the schematic symbol wizard, and here I'll click on the footprint and search for the transformer footprint that I have designed. And once we get that, we'll assign it, and we'll just ensure that all the pins are correctly assigned. None of the pins are missing in this entire design. Mounting holes are not pins, so we are not going to consider them. And then I'll click on the update footprint and click on the cancel and come back and save this particular schematic symbol. One important thing is you just need to look at the custom properties. In that, you have to change the prefix or a designator from U ? To TR ? Because transformers are considered having a TR designator according to IEEE standard or the standard of electrical engineers. Once we are done with this, we are completed with creating a component library for 12012 1 ampere transformer. Alright, I believe you have enjoyed and understood the concept of designing a schematic symbol and PCB footprint for a 12012 1 ampere transformer. This tutorial is a special one. Why? Because this will give you an idea how to create a component library for the components which does not have a standard datasheet. I hope you understood the entire concept and enjoyed the tutorial. Thank you so much for watching this video. See you again in the next tutorial. Until then, tune yourself to make a difference.